Hello, wonderful science class. On this very cold day, what we're going to be doing is we're going to be watching a demonstration on cinder cone volcanoes. What we've been talking about in class has been really focused already on shield volcanoes and fissure vents. And we were learning about how the lava, the viscosity of the lava, particularly in those shield volcanoes, was very thin and runny. And elements that we saw that, I guess, supported that fact could have been how the lava could travel many, many miles away from the vent where it came out in the volcano. And we saw that particularly in Hawaii, where it was traveling that 6.5 miles away from where it had erupted, forming this very wide base of a volcano. And even though the island itself wound up being super, super tall, it didn't form that mountain look as you were quite looking at it. Why? Because the base was so wide that lava could run so far. Also, the gas content was very low. We saw that people made tours out of going to shield volcanoes and fissure vents. People in Iceland and Hawaii were able to get close to lava because they knew that it wasn't going to explode. All right, there wasn't that high gas variability to it. Cinder cone volcanoes are different. One, they are going to have more of that picturesque like shape that's going to go up, even though it's not going to be the tallest of volcanoes, it's going to go higher. All right, the lava is also still going to be runny. But this volcano, the major feature with it is not, all right, that the lava, all right. The major feature that we're really going to be focusing on is the cinders themselves. And when we looked at volcano boarding or ash boarding, you could see in the video where it had like a granular look. One of the students said it reminded them of coffee grounds, which was an amazing analogy. That's what we're going to show today. So we're actually going to do a demonstration on cinder cone volcanoes. What we're going to do is we're going to take ammonium dichromate, right, and we're going to create our own cinder cone volcano. All right, so I'm going to move you along with me so that you can see the prep as we go about in doing this. All right, so what I'm going to do is I'm going to add the base. All right, on these volcanoes, you're going to see that it grows, all right, and what I mean by grows, all right, especially when we look at something like Paracutin, all right, a mountain can essentially form out of the depths of nowhere, all right. In this example, we're going to take this and I'm going to show you what cinders could essentially look like. So all I'm doing is I am making, my own volcano. All right, to put this in perspective for size, all right, here's my hand. So we're not talking about a large amount of chemicals that I'm using there. Being careful not to touch it as well. All right, I'm going to add a little bit of a reactant. I'm going to put in a little bit of alcohol, rubbing alcohol in it. All right, not a whole lot. All right, and then we're going to watch this reaction. All right, essentially we're going to create our own cinder cone volcano. Film correctly if I my match. I can't quite tell if I'm going to be slow to start. Try to get a better angle real fast. Sorry, I had to move out of the way there a little bit. Trying to see if I can get that in view. All right. It looks like most of it has reacted. All right, and I'm gonna put my hand here for comparison again. So now you've seen that this has grown quite larger. All right, so from being right above the top of my hand to now you can see this volcano has formed. All right, and then essentially the comparison of the cinders on the edge. All right, similar to that you saw in the volcano boarding. All right, and how that would grow. All right, you can also kind of see, let me make sure my dog doesn't eat this. Sorry. I'm trying to see if I can show you the crater at the top. Grab a matchstick. Doing this upside down is quite challenging. All right, the depression right around there, all right, being the crater. All right, where it's kind of sifting down. All right, so that is a demonstration for the cinder cone volcano. All right, and that difference, you could see the explosiveness of it, which is why this is going to be coming up with a higher gas pressure. All right, but still the same lava, still that same thin runny lava. It's really not going to be coming out as much from that center crater, all right, or that main vent. That would be more of the cinders. All right, that lava coming out more from the lower areas, all right, but not expanding out like we saw in the shield volcanoes.